Hi, everyone. So we are on page 47 in the book. It's called, we're on lesson 3, f of x. And if you look right here, this was the do now. You're just going to read this part. And there were two ways to do the domain and the range, right? So one was with just using the words and one was with using the notation. And then notation, there are several different ways to do the notation. But the way we're going to learn this time is going to be with inequality notation. Okay, and we notice we have these two graphs right here. And so this is g of x and this is h of x. I know it's kind of hard to see, but if you had your book, you could see that. Okay, and if you notice right here, this is not an arrow. I should probably erase that for you so you can see that. Do you see how that's not an arrow? So it does not keep on going forever and ever. So it does have a starting and stopping point. So it starts right here and ends right there. Remember, the domain is talking about the x. So how far left does it go and how far right does it go, right? So how far left it goes all the way up to -7, right? And can it equal -7? And if you look right there very closely, it is closed, right? So a closed circle means that it can't equal that. And most points are going to be closed circles, right? Because we're trying to find the points that it can be, not what it can't be, right? But then every now and then you'll see that something like this. You see over here on the right, it's an open circle, right? Which means it does not include that point, but anything right up until 6, it'll totally take that. So 5.99999, it'll take that, right? But just not 6, right? When it gets to 6, it's whole, doesn't work. All right, so that's what we have from -7. -7 is less than or equal to x, which is less than 6. And notice there's no equal to sign there. It's just the less than symbol. All right, and another thing to note, and we'll just talk about that. So that's the x. And then for the y, how low can it go? If you look at the y-axis, the lowest the graph ever goes is to -2. Right? Can it equal -2? Yes. Because if you see, there's a whole long line right here. So it's equal to -2 for that interval right there. So we're going from -2 all the way up, I should say, to that's 8 right there. Yeah, I don't know if you can see that, but that's an 8. All right. And then there are no open circles on any of this stuff. So yeah, that's a closed circle. These are all, it can't equal to it. So yeah, that's why we have -2 is less than or equal to y, which is less than or equal to 8. And this variable is going to be whatever it is. So if it's y, if it's range, then it's y. If it's domain, then it's x. Okay. And for h of x, notice it's exactly the same thing as g of x, except there is one difference right there. If you, oh, where's my mouse? There you go. I'm going to just erase this guy for a little bit there. So if you notice right here, this does have an arrow. An arrow means that it goes forever in that direction, right? So it's, if you think about directions, like with the compass and all that, so this is going southwest, right? So when we're talking about the domain, that's talking about the east and west. How far west and how far east, right? So how far to the left are we going to go? Well, if it has an arrow, that means it goes on forever and ever to the left, right? So we don't care about south right now. We're just talking about how far left. So if it has an arrow that's slightly pointed out to the left-hand side, it's going left, right? And so it's all the way to -infinity. And then do you see how this arrow right here on the right-hand side goes on forever? It's going southeast, right? So it is going east. It's going in the southern direction, but it's still going east, right? So it is going right, which means it's going on there forever and ever. So the way we say that is this. In words, we will say the domain is a set of all real numbers, right? And it comes to this idea of, well, then aren't all numbers real, right? And we talked about that before. Anyways, it's going to go from -infinity to +infinity. And remember, you have to put in the x in the middle, right? To show what it's greater than or less than to, right? So it's -infinity is less than x, which is less than infinity. And notice right here, we have no equals to, because you technically can't equal infinity. If you can get equal infinity, that means you haven't gone far enough. Like, can you ever reach forever? No, you can't reach forever. It's just a concept. It's an idea, right? So you can never reach infinity. So that's why it is always going to be this less than, never going to have the equal sign under that. Okay. And so both ways are ways that you could write the domain or describe the domain. And then for the y, if you notice right here, it does have arrows going south, but it has no arrows going north, right? So it doesn't have any arrows going up. The highest number that the y could be is 8. 8, that's as high as it's going to be. So, oh, if I can, so 8 right there. So it caps out at 8, and it could be anything lower, right? So we could say y is less than or equal to 8, because at 8, there was no open circle there. If you want to go in with this similar format, you could say, you could include there the negative infinity is less than y, which is less than or equal to 8. Sometimes people do that. It's unnecessary because, you know, negative infinity is included with being less than 8, right? So that's why that's part is extraneous. You don't really need that. But if you put it in, it's not wrong. It's just more writing that you just did. All right. And then what I would do is, if you were not in class, I would look on this one. This is the card sort, which was on lesson 2. If you go to lesson 2, and this is going to be on page 29. So 29 and 31 and 33 and 35. So this card sort is like ginormous. Okay, it's a very big card sort. So if you can cut those out, that would probably be the best way to do it. But if not, that's okay. If you want to just tear those pages out and then you just want to write on them, that's okay too. All right, so that's where that's at. But we just did the first 6. Okay, and I would pause right there and then just work on the domain and range, see if you could get them right. That's a good way to practice. If not, if you already done a thing, then there you go. Then you can just fast forward if you want to. It is up to you. It's choose your own adventure. All right, so if you look at this one, notice is the domain, we do have an arrow that goes to the left and an arrow that goes to the right. Not exactly to the left, but it's slanted, right? It's towards the left and towards the right, which is fine, which means that it's going to be, again, all real numbers, right? So from negative infinity to positive infinity, that's for A. Same thing with the range. We have an arrow that points down and an arrow that points up, which means it's all of them, all the real numbers, right? So from negative infinity is less than y, which is less than infinity. Always is going to be less than. You don't ever see it to be greater than. You can, it's just not common procedures, right? It's not standard practice. And if you were like me and you were confused, well, which one is less than, which one's greater than? Like I know, like, the alligator eats the bigger one, but I'm like, what is it called though? What is its name? Because if my teacher asked me, like, how do you say this? Like, let me write it down. So how do you say this? I'm like, X is, like, I don't know, right? Because if they did something like this, then I'm like, oh, 6 is greater than 5, because I know in my brain that 6 is bigger than 5. So I would know that it's greater than, right? But if it was just an X, I was like, I don't know. So actually, when I was a teacher, so I had to kind of like just try and memorize it because it was just so confusing. But they had taught me this. One of my middle school kids taught me this back when I used to teach middle school, right? And if you look right here, so you have the two symbols like this. And then you're like, okay, which one looks like the L? This is what they asked me. Which one looks like the L? I'm like, oh, the left one. That's less than. So do you see less than? I just wrote down less than. And then if you're like, well, what about this one? You're like, well, if you put a half circle on there, now what does it look like? Oh, a G, greater than. I'm like, oh, that's genius. So if only they taught me that when I was younger, then I would have had stressed out less. Right? And if you notice, if you put that same thing over here on the L, you get Pac-Man, not a G. Okay, so you can definitely try that out and see if that will help you out. If you're one of those people, if you were like me and had struggles, like I struggled all the day long on that. Okay, we'll go with blue. Again, if you take a look at this guy for B, again, the domain, we have arrows that point a little bit to the left and a little bit to the right, which means they're all real numbers. Okay, so from negative infinity to positive infinity. And then for the range, it has arrows pointing down, but definitely not pointing up, which means that it has that max point at 2. And I know that's 2 because this is going by 2s because it goes up to 10. There's only 5 tick marks, right? So that's going to be 2. So again, that's going to be negative infinity is less than y, which is less than or equal to positive 2. If you wrote down just y, if you did not have this part down, that's good. Okay, but if you get in that habit of, doing these two inequalities, that's okay. That'll actually get you ready for a different kind of notation called interval notation, which is amazing. My Algebra 2 kids are learning that right now, or have learned that already while they're doing domain and range. So again, this domain and range stuff does not leave you. It just keeps on coming back. Okay, so Sure. Remember. Okay, it's coming back in algebra 2. All right, so if you take a look at this guy again, arrows pointing left, arrows pointing right, which means domain is all real numbers. And usually domain is all real numbers, but not always, but usually. Okay, so here from negative infinity to positive infinity. And range, the lowest point here is going to be, so the minimum point is going to be at 0. We're looking at the y value, not the x value. We don't care about left or right when we're talking about range. So how low it's going to go is at 0 all the way up to positive infinity. So it's going to be 0 is greater than or 0 is less than or equal to the y, which is less than infinity. Or if you want to just flip that, it's just go y is greater than or equal to 0 if you want to. You don't have to. And if you take a look at the circle, right, we definitely have the left-hand side does not go any more than -4, and it goes all the way to +4. And that's true for the range as well. That's why you'll see that to be the same, because that's as high and as low as it's going to go. All right, and then for E, notice that these are just points and they're not connected, they're not continuous. So we have to state these exact points. So X is going to be, so for the domain, you have as low to the left as -2, -1, 0, 1, and 2. Okay, and then for our range, we have only 3 possible Y values, right? So 1 down here at -8, then +1, then at 4. Okay, and notice they're in numerical order. So you don't just mix them up. You don't go like 4 and then -8 and 1. We always put it in numerical order. Easy to find that way. And then, and if you remember, this is called discrete, right? That's a discrete function. And this one right here is a continuous function, because you can draw the whole graph without picking up your pencil. And again, we have an arrow pointing left and an arrow pointing right, all real numbers. And for F, arrow pointing down, arrow pointing up, all real numbers. Okay, so that's going to be from negative infinity to positive infinity. All right, moving on. So now we have increasing, decreasing, and constant functions. And what we had noticed, an increase, always the way I like to think of it is like if you have a little car, right? If you have a car and we're always going to go left to right, okay? And if the car's riding the graph, is it going up or is it going down, right? Or constant would just be going straight across, right? And so that's how you would know if it's an increasing, decreasing, or a constant function. But the more official term is because when we're going to the right, oh, that's like a weird right. Let me do that one more time. So sorry, as we're going to the right, remember our x is getting bigger, right? So as our x is getting bigger, if our y is also getting bigger, you're going to do this. Okay, so that's increasing. So as x is getting bigger, and then let me do a different color, and your y's are going down, that's decreasing. Okay, and then as your x gets bigger, y don't care, like y is just going to keep on keeping on. That's going to be constant. Okay, so that's the difference between them. Okay, so it's always from left to right as x gets bigger. Okay, not x gets smaller. Well, as x gets smaller, then it just gets all weird and crazy. All right, so and we went over here to the card sort, which is again at the back of lesson 2. And if you notice right here, we did a couple of reasonings here. So we had F as increasing. Do you see my car right there? Yep, there's the car. This one is decreasing. M was decreasing. G is also decreasing. Notice A is decreasing, then it goes constant, then it decreases again. Okay, and then here we have, again, remember it's from left to right. So if you have our car, it's going to go increasing and then decreasing. Again, and then here C is decreasing, then increasing. All right, and this one, if we're going again left to right, so it's kind of like hopping, right? We're hopping from stone to stone, right? That is increasing and then decreasing, right? And this one again is slowly increasing and then quickly increasing, right? This one, number L, or no, letter L, that is decreasing. You're going down the steps, right? If you were to hop down the steps. And if you look at O, you're like, what in the world is O? If you go from left to right, there is no left to right. There's just straight down, right? This is called death. I'm just kidding. This is neither increasing nor decreasing, and it's not, it's just, technically this is not a function, so it doesn't even matter, because if you look at the question, it was about increasing functions and decreasing functions. And this one's like, O is not a function. How do I know that? Because it does not pass a vertical line test, right? Because here's my vertical line. Here's my vertical line. So how many, do you see how it totally matches up? How many points does it intersect at the same time? Infinite number of points, right? So this does not pass the vertical line test. Almost all of these though do. So these, see how it only crosses at 1 point at any given time? Yeah. So even this one, we were like, oh, maybe, no, exactly, only passes at any given time once, right? Same thing with this guy, same thing with this guy, right? And this one right here. Oh, see, D crosses 2 points right there. So that even if it's at one time, it's not a function. So this is definitely not a function. Circle is not a function. If you try to graph this on your paper, on your graphing calculator, it will not, it will break your calculator. You're not really, but it'll say error. It can't do that, right? Because computers cannot compute functions. They don't understand it. It's like they can't divide by 0, right? They have some limitations. I know, crazy, right? Okay, so there is the increasing and decreasing, and we're going to go back. All right. Now we're going to take a look at, let me see if I can do this. So we're going to use Desmos. If you have not downloaded that app yet, make sure you do. And so what we're going to do is we're going to use the graphing technology to determine, so Desmos, determine the shape of its graph, right? And then we're going to match the function to its corresponding graph by writing the function directly on the graph. Okay, so here we go. We're going to do some writing here. And I'm going to take, so if you notice right here, we're going to do a little bit of writing on here. I just copy this down so that I don't have to keep on going, scrolling up and scrolling down. Right, for you, you're going to have like, it's going to be on, you know, other page and stuff like that. So right now, so far, we have 2 different kinds of functions. We have the linear functions and exponential functions. If you notice right here, a linear function is going to look like this, ax plus b. Okay, notice it has one variable. The a and the b are actually just numbers. You're going to see them as numbers here. And x, yes, technically is a number, but we don't know it. That's the variable, right? It can change, right? The a and the b are constants. Okay, notice the x has no exponents, right? But notice for the exponential, what is the exponent, right? Where's x? If you look very closely, the x is the exponent, right? That's why you call it exponential. Okay, so that's where that is. So whenever you see a little x like that as a power, that means that we're talking about exponentials at this point. Okay, so if you look right here over on the right hand side, you're like, well, which one is linear and which one is exponential? And if you look right here, this is just x by itself, which is kind of like this. What is our a? A is, remember, there's that invisible 1 in front because 1 times x is x. We just find it irrelevant to write down the 1 in front because, yeah, you don't need to. We already know that's just 1x. And then plus b, there's no plus b, which means that there's a plus 0. All right, so this is definitely going to be linear, and we will check these as well. And this one, notice the, right? Just do it by yourself first, unless you don't want to, but you should. That would be better. So here we go, and the exponent is in the exponent. Exponent is, x is in the exponent. I can't talk. So this is going to be exponential. I'm just going to go exp. And this is also going to be exponential, right? Because of that exponent for the x. X is the exponent. And this one is 2, where x is an integer. Oh, this one is also linear. Notice the x, we would normally call this constant, right? But it does make a straight line. You will soon see. And again, this one, x is the exponent. So we're going to exponent. This is going to be linear. Okay, and then we're going to just take a look at these guys over in the other place. So I'm going to go copy. And we're going to go back to the card sort. And I'm going to paste. And we'll just kind of, where can I put that? Put that like right up here. Something like that. All right, so if we take a look at this, we're going to first do the first one. So if you go to Desmos, or if you have it on your phone, that would probably be better. And we're going to look at just f of x equal to x. So all you need to do is that x part. You don't need to put y equals x or f of x. It'll kind of confuse the computer. We'll just put x. And notice right here, look, straight line, it goes right through the origin, right? And it's increasing, right? Because we're going from left to right, it is increasing. So let's take a look. Which one is that like? Ooh, look, that's got to be this one. So we'll write this down in blue, and we'll say this is f of x is equal to x. That's the function. All right, now and it is, see, it's a line. That's what we said. And so this is 1/2 to the x power. So we're going to go, I'm going to 1/2, which is 0.5 to the x power. Oh, not 2 power, x power. There we go. And it's going to look something like this. It crosses, notice there's a point right here, it crosses at 0, 1, and it is decreasing, right? So we're going to take a look at this guy right here, and we're going to see, is there anything like that where it decreases? And I'm going to just move this on over. Oh, just go like that. And we're like, oh, it's right here, decreasing, right? So this is going to be our f of x is equal to 1/2 to the x power. All right. There we go. And then we're going to do some of the other ones. So 1/2 to the x minus 5. So this is really close to what we were doing before, except we're just going to have to add in a minus 5. And notice what that does. That just brings that right down, right? So the exact same shape, still decreasing, except it's just lower. Okay. And so if we go over here, we have to ask ourselves, well, what is that? Let me move this guy over here. There it is. It was hiding. Okay, so this one is going to be it. So this is f of x, and this is going to be 1/2 to the x power minus 5. All right, and then we have just 2, where x is an integer. So this one, I can't really show that here, but we can see what the continuous line would be, and then just make sure that we have like dots or points, right? So where x is just, here it is, it's just 2. Oh, I should probably say x or y equals. Oh, there we go. Because it just didn't understand 2 because there was no variable. Like, I don't know what to do with this. So here we go. Y is equal to 2. Notice straight across. All right, so that's going to look like, oh, but it's an integer. Remember, it's just integers, so just numbers, the like whole numbers, but with the negatives. So yeah, that's going to be r. So this is going to be f of x is equal to 2. And that makes sense because do you see how there's no x in there? Literally, x, it does not matter what x is. Y is always going to be 2. You don't care. And that's exactly where it is. It doesn't matter what x is always 2, or y is always 2. So that's why the point is just going straight across. All right, and then where x is an integer, that is important. That talks about that makes it discrete. And then this is going to be 2 to the x power. So I'm imagining it's going to be a little bit like the other one, our other exponential one. There we go. Ooh, except it's increasing. Okay. Oh, remember the other one, y is equal to 2. That's just constant. All right. So if you look right here, it's increasing. It crosses here at 1. So let's see which one does that here. Crossing at 1 and is increasing. Ooh, right here. And was it supposed to be an integer? And you're like, oh yeah, where x is an integer. There we go. So we're going to write down f of x is equal to 2 to the x power, where x is an integer. All right. And let's see here. Last one right here. This is negative x plus 3. So we said that that was going to be linear. So let's find out. So this is going to be negative x plus 3. Oh, look, it crosses here at 3. And it's a negative, right? It is going to be, it is not increasing. It is decreasing right there, right? So we're going to look for the one that goes like this, except, and it crosses here at 3. There we go. And it's all integers. So there we go. So it's going to be f of x is equal to negative x plus 3. I believe I got that right. Negative x plus 3. Yep. And then where x is an integer. All right, and those are all the equations that we found so far. Okay, and for the, let me go back. Okay, so we're going to go right over here. And so we are going to be talking about the 3.4. We'll finish it up on Wednesday. So make sure you look out for that video, okay? Bye.